Okay, let's look at our final evidence project and turn to project 2, the testing house paint for lead project. I want to look at the questions that are on the very back. I'm going to focus on questions number 2 and question number 3. They have to do with the way that the periodic table is arranged and what that tells us about the properties of elements and how we can predict the properties of elements. So what we know about the periodic table is that it's arranged into 18 groups, those are the columns going up and down, and 7 periods going across. The reason that it's arranged in groups like this is because when the periodic table was originally conceived by Dmitri Mendeleev, he arranged elements into groups that have similar chemical properties. There was a repeating pattern in the properties of elements when he arranged them from the smallest up to the largest. He kept going, but he started over a new period or a new row when the properties of the elements repeated themselves such that they ended up in columns, we call groups, of elements that have similar chemical properties. So we did an experiment where we looked at the elements that were in these two groups right here. We're going to recap some of the main ideas from that. So when we were doing that experiment, we focused on elements that were in group 1 and 2. We looked at lithium, sodium, and potassium, and magnesium, calcium, and strontium. These are solutions that contain those elements in compounds. And we were looking at 2 different test substances, carbonate, and we also used phosphate. And we put them into these to see if they would react or not and form a cloudy mixture. So when we tested the elements that are in group 1, lithium, sodium, and potassium, we observed that there was no reaction. That was something that all 3 of these substances had in common, that these elements didn't show any reaction with the carbonate. But when we tested the group 2 elements, we observed that there was a cloudy precipitation reaction and that there was something happening there. And that was the same in all 3 of these substances that contain those 3 metals. They all were reactive with the carbonate. And so we made a prediction, what if we tested barium? And what would happen with that one? It's the same group in group 2, different substance. We predicted that since it's in the same group that it would have similar chemical properties, and in fact it did. We related that to the electron configurations of these elements. When we looked at the electron orbitals of these elements, the ones that were in the last or the largest electron energy level, the valence electrons in this case, we saw that all of these elements had 1 valence electron in an s orbital, and these all had 2 valence electrons in an s orbital. And so the similarity in the valence electrons is what explains the similarity in the chemical properties. These all react the same way. They're in the same group. They have the same valence electrons. These react the same way. They're in the same group, and they have the same valence electrons. So based on that, I came up with a question about the lead test. We're trying to find out if a sample of paint contains lead. But there are a lot of other metals that might be present in paint, and so we want to make sure that we can rule out all of those other alternatives. So we have to have a way to know for sure that when you see a positive test result, that it's lead and it's not something else. One of these elements you would predict would be similar to lead in its reactivity, and so if we did the experiment and we saw a positive result, we'd have to have a way to rule that one out. We'd have to add some extra steps and some extra samples. But you should also be able to explain which of the elements it is that we would expect to react like lead and why in terms of its valence electron orbitals. So keep in mind the experiment that I just demonstrated, and you will have an answer to that question.